In this video, I want to talk about principal nth roots, and these are, well, they're kind of like square roots, but with different numbers other than 2. So it turns out that square roots, well, those are numbers that, like what number times itself would equal that number. Okay, well, now I want to look at things like cube roots. So what number times itself would equal 8, say. So here, this has a little 3 on it, okay? So it's like a square root, but the 3 tells me it's not 2 times, but 3 times. So what number times itself 3 times is 8? Well, that's 2, okay? So that may seem a little strange, but this is actually necessary for us to continue on. So I want this little 3 here tells me we're no longer doing square roots, but we're doing cube roots, and it's asking what number times itself 3 times is 8 as opposed to 2 times. All right. Now let's look at some examples. What would be the cube root of 27? What number times itself 3 times is 27? Okay. Well, I think that's actually 3 itself, right? 3 times 3 is 9. And 3 times 9 is 27. Okay. Well, what number times itself 3 times is 64? What is the cube root of 64? Well, it's not 3 for sure. So let's try 4. 4 times 4 is 16. 16 times 4 is 64. Yeah, it looks like it's 4. Okay. Now, this example is the 5th root. So what number times itself 5 times is 32? Okay, well, what do? You can either punch this in a calculator. Calculators do often, scientific calculators often have a way of inputting this information, but by hand, how will we do it? Well, let's see. Well, let's try 2. So 2 times 2 is 4. Well, I know 2 cubed is 8, times 2 is 16, times 2 is 32. Yeah, so this is 2, all right? So this is the 5th root. Again, most scientific calculators have a way of inputting this, so I'll calculate it for you. But by hand, we just have to be kind of creative in our guesses. All right, negative signs with odd powers. Okay. We didn't have to worry about these with square roots. We do with odd powers. So I've already talked about the cube root of 8 equals 2. Now what about the cube root of negative 8? So we didn't deal with this with square roots. But this is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. So you can have negative numbers with odd exponents. For instance, what number times itself 3 times is 253? Okay, well, is it 4? Let's see, how are we going to find this out? So let's try 4. 4 times itself 5 times. That's too many times. What about 3 times itself 5 times? Yep, that works. So this is 3. 3 times itself 5 times is 253. Okay, well, what about the 5th root of negative 253? Because this is an odd power, I can have that, okay? And to show you, I'm going to show you in a different color, just in case that's still confusing. Again, I'm saying that, like for this, for the cube root of negative 8, negative 2, negative 2, negative 2 is negative 8 because you have an odd amount of the negative signs, okay? So I hope that helps. Again, here I'm saying that negative 3, negative 3, negative 3, negative 3, negative 3 is negative 243. Again, we have an odd amount of negative signs, so the answer is negative, and that can happen with an odd amount. With an even amount, you're always going to get a positive number. Let's talk about rational exponents. What if the exponent is a fraction? So if you have some number with 1 over n, that means it's the nth root, okay? And then we can also have a number with just a fraction where it's not just 1, and there's two different ways we can manipulate that. So the n is still the nth root, and you can take it to m, or you can take the nth root and then have the number to the m, okay? I'm not going to prove that that's true in this video. I'm just going to use that statement is true. So let's try this. 4 to the 1/2. Okay, well that would be 2 to the 4th. And 2 is understood to be the square root, so we don't actually write the 2 here. So what is the square root of 4? It's 2. Okay, so that's the answer there. What about the square root of 1/4? So this 1/2 would be the square root. So what is that? Well, by the quotient rule, we can say that that is 1/2. Square root of 1 is 1. Square root of 4 is 2. Okay. What about the 1/36 to the 1/2? Well, that's the square root of 1/36, and that's going to be 1/6, because the square root of 1 is 1 and the square root of 6 is 6. So we can just use the quotient rule, skip a step, and just go right to the answer. So these are the answers for that one. Okay, what about 32 to the 1/5? What do you do for that? So that is the 5th root of 32, okay? And I think we just talked about that is 2 itself. 2 times itself 5 times is 32. Okay, so that would be the answer for that. What is so I can understand this is the 4th root. What is the 4th root of 81? So we haven't done this one yet. And I'm going to try 3. And yeah, it's 3. So 3 times itself 4 times is 81. All right, let's talk about how we can do it with algebraic expressions. Here, we're taking the 4th root of y to the 24th, q to the 24th, over 16. And by the way, this is coming from problem 22. Well, I'm going to kind of cheat, and I'm going to go the other way, because I think it will actually be easier to go this way for this particular problem. Why do I say that? Because I can distribute the 1/4 for these exponents. What's going to happen? I'm just going to divide 24 by 4, 24 by 4, and I do have to do 16 1/4. And I'm kind of running out of room here. I'll go down a little bit, but so this would be y to the 6th, q to the 6th, and that's over 2, because 2 times itself 4 times is 16, okay? Again, I hope that helps. If you have any questions, please let me know. Thanks.